Hello everyone. So in my previous concepts I covered very basic concepts in motion. First is speed. So we can write that speed equal to distance upon time, or this is also called distance is also called path length. Path length upon time. So we are representing that as x upon t. Then after I talked about velocity. Velocity equal to displacement upon time. So displacement also we used to represent as in terms of x upon t. Then after average velocity, so this is something is important. Average velocity is equal to final minus initial displacement minus, we need to have two displacements, so the average velocity between 2 points, we can calculate that x2 minus x1 upon t2 minus t1, which also we can write that as delta x upon delta t. So here delta means nothing but change in the position. So we represent average velocity are v suffix bar. So whatever the line we draw on the top, so that gives us average velocity. So what about the average speed? Average speed equal to total path length upon total time. So the total, if you can take from initial to final, the total if we can sum up, that gives the total path length upon total time. So this is about speed, velocity, and average speed. And if I talk about its units, if you can take that units, speed units are nothing but meter per second as a unit, velocity also meter per second, average velocity, everything is meter per second. Now we talked about acceleration equal to acceleration A equal to the rate of change of velocity, change in velocity, v2 minus v1 upon t2 minus t1. So this also you can write as delta v upon delta t. So delta means nothing but change. In physics we used to represent delta, so the triangle, not mathematics triangle, so it's physics, so that we call as delta. Change in, delta represents that change in velocity by change in time. So acceleration units are meter per second upon seconds, because meter per seconds are velocity units, so we can write that meter per second square are the acceleration units. Since velocity is a vector, so acceleration is also a vector. Now today's class I would like to talk about much more about how we can find velocities from graphical representation. In earlier class we draw graph for position time graph, so x versus t graph. So these are the three kind of the graphs we know, that x versus t, position versus time. If this you can take on the y-axis as position x and x-axis time, it's time, and on y-axis it's the position. If position time graph, it is representing a straight line which is parallel to x-axis. So it is a straight line which is parallel to x-axis, and this graph tells about the motion the motion of the object is the object at rest. The object is at rest. So that is the meaning of the graph tells to me. Now if this is position time graph, what could be velocity time graph? So I would like to draw velocity time graph for this one. So velocity, if we can take the x-axis as velocity and time. Velocity time graph for object at rest. So from position time graph or by using position time graph, how can I find that velocity time graph? I know only one formula till now, that is velocity equal to change in position. I would like to write in terms of formula x2 minus x upon t2 minus t1. Suppose for your understanding, let me take numbers at here, that is 20 and this is at 20. It is time 1, 2 and 3 and 4. Time is in seconds. Now I would like to find between the points. I would like to take 2 points. So at t equal to 1 second and one more point at t equal to 3 seconds. And I would like to find what is the velocity in between these intervals t1 and t2. Forget about the rest of that ones for a moment. For a moment, if we can take that in between. So if we can substitute in this formula. So if I can take this as t1. So 1 it is time initial t1 and 3 it is time final t2. And the corresponding value at here it gives to me x2 and the corresponding value at here x1. See, they both are having same value. So if you can substitute that at here velocity, the x2 value is 20 minus x1 value is also 20 upon t2 minus t1. I have to subtract 3 minus 1. So velocity equal to 0 by 2. 0 by something goes to 0. It means if I draw a velocity at that particular segment, only at that particular segment. Suppose if I can draw the velocity in this segment, in between the time t2 to t3, where should I draw? The velocity is 0. So it means I need to draw a line on the time axis. So in the time axis, the velocity component is 0. So I think it is visible to you, or I can take that as big line. Yeah, by this formula, what we got from the formula, the velocity is 0. Where would we represent in the graph? We have to represent in the 0. Suppose if I want to find from the initial, the starting position to final position. If I want to find the initial position to final position, so how can I represent the graph? The graph will represent it from the starting to up to here. Okay, so finally I can conclude by saying this: if an object is at rest, that is representing with a straight line. So if the object is at rest, so this is a position. So this is the position versus time graph, and to this the corresponding velocity versus time graph. I can take that, yeah. To this the corresponding velocity versus time graph is how it could be. So this is also we need to draw velocity versus time graph. Sorry. If I take that as velocity, let me take x-axis first here. So this is velocity versus time graph, but I need to draw a line which is on the x-axis all the way, it goes to 0. So this is the graphical representation for an object is at rest in the position versus time graph, and where it went. And to me, so on the velocity time graph, and this is the graphical representation on the velocity versus time graph. So this represents velocity versus time graph 0. It represents the object is at rest. Now let me take another variety, position time graph. So the second variety of position time graph, suppose this is coordinate axis, a line which is passing through the origin. Suppose if I draw a line which is passing through this origin. Now this represents as position x and this is time. So this line represents the object is in uniform motion. The object is in a uniform motion. So if this is the position versus time graph, how shall I draw velocity versus time graph? So I would like to draw for this same setup velocity versus time. So if this is position versus time graph, how it looks for velocity versus time graph? So in this case, how it would be? Now if I know the position and I would like to find the velocity. So for that I will come back there, but I would like to recall your mathematical knowledge, that is, suppose this is coordinate axis. So this is, let me take x-axis and this is y-axis. Suppose it is supposed to be as y-axis. Now we have a line, a straight line. It is a straight line. In mathematics, this straight line can represent with the equation. The equation for a straight line. What is the equation for a straight line? That is y equal to mx plus c. Yeah, something is ringing bell. Yeah, this equation we know that. So here m is known as slope. What the slope formula can give? Slope m equal to y upon x. So to calculate the slope of this curve, I need to calculate the slope of this curve. For that, I need to use this formula. Or if you remember this formula very specially, m equal to y2 minus y1 by x2 minus x1. This is also another formula we can use if you are having 2 points to represent. Okay, now let me consider at here on x-axis 2 points. So this is one of the point. I would like to find the slope at the two locations. That's one of the location which I selected, and another location let me take somewhere at here. Let me take space, and the corresponding y-axis, if I take a line from the corresponding y-axis at here, oops, if I take line corresponding point from at here, so that is the corresponding point, and one more point along the y-axis, I take this one. Now if I know the corresponding x values at here, now for a moment let me take the x values. So here it is 1, and it is 2, it is 3, and it is 4. And the corresponding y values, if I take as my wish 0.5 or 0.1, sorry 1, so it is 1, it is 1.5, let me take as 2.0. Now let's calculate slope. In this case, slope m equal to y2 minus y1. Which point is y2? So this is y2 higher, and this point is y1. The slope of this line, which equal to 2 minus 1 and the corresponding x2 minus x1. So here x2, this is x2 4, and x1 equal to 2. So 4 minus 2. So I can get 1 upon 2, which equal to 0.5, which is slope. So that is the way to calculate slope. So you might be thinking, why I am calculating slope at here? Because now I am going to change its names. So how would like to going to change its names? Suppose if I take this as a part, now I will make small changes. So this one I don't want, and instead of x and y, I'll change this as this is 2.0. And now this is my time axis, and this is my position, x position. Now it became my position versus time. Now what is the velocity formula? So the velocity formula, we can write that velocity v equal to x2 minus x1 upon t2 minus t1. So velocity v equal to, here the x2 I have taken, this is a 2.0 minus x1 I have taken 1.0 upon t2 here it is 4 upon, sorry, minus 2. So velocity equal to 1 by 2, which equal to 0.5. So this line represents in the position versus time, it's a uniform motion. So I would like to say finally, if you know the uniform motion graph, to find its velocity, what we need to calculate? We need to calculate slope of the curve. So this straight line slope, or in mathematics another word it is having, that's called as a gradient. we need to find to velocity, we need to figure it out its slope. Now by seeing this graph, we can understand this is having positive slope. Not only that, suppose if you take the slope of the curve, now instead of finding from the between the positions, suppose if I want to find this from the initial to final, so I would like to find the slope of the curve from the initial to final. So let me take this for small clearance. I want to find the slope of the curve from the initial to final. 1 second. So here the initial point is 0 because you can see the graph is at origin and the final point is at O. So in order to find from initial to final, suppose if I take a line from right way at here to 4, so this is my final point, and the corresponding point at here on y-axis, so this is my y-axis point. Now the slope of the curve, so this is the curve, so this is the curve slope, so this one I want to find it out. Now in the y-intercepts, 2 points I need to know. So the point itself is touching at y-intercept is 0, that is initial. So I can take that y1 equal to, sorry, we are talking about position, so I can use word as x2 minus x1. So x1 equal to 0, the corresponding t1 also equal to 0, they both are at origin, and x2 equal to 2.0 and the time t2 equal to 4.0. So velocity formula we equal to x2 minus x1 upon t2 minus t1. So velocity v equal to, we can find out that 2.0 minus o upon 4.0 minus o. So velocity equal to 2 by 4, which equal to 1 by 2, which equal to 0.5. So I want to say that wherever you find, since it is straight line which is passing through origin, it's having same slope. Slope is same. So it is not non-linear curve, it is a straight line curve. So its slope is same. Oops. So I can say that slope is same. So wherever you find on the line, so it gives same slope value. Now how we can represent this in the velocity time graph? Now wherever we find slope, suppose I want to find slope at whichever the position, since it's straight line from here to there or here to there, any point if you find, so the slope is constant, it means velocity is constant. Velocity is constant. Or I can make one more statement, if the motion is uniform, the velocity is constant. If motion is uniform, the velocity is constant. So where I got the velocity I got just 0.5, and that velocity throughout the time is constant. So constant means it do not change. So I will draw a straight line which is parallel to time axis for that. So if this is position versus time graph, if this is position versus time graph for uniform motion, and the corresponding this is the velocity versus time graph, velocity versus time graph. So now this velocity is constant, but it is not touching on the origin. I hope you are understanding the differences. So but in the above cases, what we talked at here, if this is the position versus time graph for an object is at rest, so now we have to plot the velocity versus time graph, a line which is on the x-axis that goes to 0. But now in this case, it is something is different. If it is a uniformly increasing uniform motion, the velocity versus time graph is constant. Now what about for non-uniform motion? So before the non-uniform motion, I would like to think about, suppose if this is my position versus time graph. If this is my position versus time graph, little change. So this is my position versus time graph, x versus t. Can you guess what it would be velocity versus time graph? What it would be velocity versus time graph? Think about that. Now this time the slope is downward. So now I can say the object initial velocity at here, sorry, initial position. So this is the initial position. Why it became initial position? Because here the time, when the time t equal to 0, the object is at here. Now when time becomes t equal to, let me take as 10 seconds, where is the object position? This is the final position. Now here the final position is at origin, the final position is at O. Now if this is the case, try to plot what could be the velocity versus time graph. Now we talked about an object is at rest. An object is at rest. So this is the position versus time graph for an object is at rest. And the second case we talked about an object is in uniform motion. An object is in uniform motion. So now I would like to talk about position versus time graph for an object in non-uniform motion. Object moving with, or simply take object in non-uniform motion. So if you remember objects which are in non-uniform motion, how the graphs look like. So if this is position versus time graph, if object is in non-uniform motion, something like curve shape we used to represent. So this tells about this line, this curve, it should not line, it's curve. This curve tells about the object is in non-uniform motion. The problem with non-uniform motion is object do not have constant velocity. If object covers unequal, is having unequal distances in equal intervals of time. When it is unequal distances, obviously the object velocity is not uniform, not a straight line. So if this is the case for non-uniform motion, how we can plot the position versus time graph? So how we can plot the position versus time graph? Or before that, I would like to calculate what is the velocity in this case? Velocity for non-uniform motion. So even it's uniform motion or non-uniform motion, we know only velocity formula. Velocity v equal to x2 minus x1 upon t2 minus t1. So this is the one and only formula till now we know about velocity. The same formula will be applicable whether it is uniform motion or non-uniform motion. Let me take one example for better understanding. So this is one of the example which is given in our textbook. So this curve represents about non-uniform motion. Non-uniform motion, position versus time. Now, to draw velocity versus time graph, first of all I need to calculate velocity. As per given there, let us calculate first what is the average velocity between points P1 and P2. So average velocity between P1 and P2. So if you write the average velocity formula, so average velocity V bar equal to, so V bar equal to x2 minus x1 upon t2 minus t1. What is the x2 value? So it is the highest value here represented as 27.4. V bar equal to 27.4 minus x1, x1 value here it is 10 upon time t2. T2 here it is 7 on the x-axis minus T1 here it is 5. Now the average velocity V bar equal to 27.4 minus 10, it is gives to me 17.4 upon 2. So if we can divide that, we can get in terms of, so roughly 9 twos are 18, so 8 twos are 16, 8.7. So 8.7 is the average velocity between 5 and 6 when the time is 5 and 6. So this is the average velocity between in that time interval. In this time interval only, that is the average velocity between in this time interval. Suppose if I change the time interval, now for me I like to take one more point. Let me take this is point P3. Let me write that as big. So this point at 3 is P3. Now what is the average velocity between P1 and P3? Find average velocity between P1 and P3. So the average velocity between P1 and P3 equal to V bar equal to, same we can write that x2 minus x1 upon t2 minus t1. So here x2 value as P1, so that's value here itself 10 minus x1 value, if I take this as a parallel line at there, so I'll consider this as number 2. So 10 minus 2 upon the corresponding time 5 minus 3. Now 10 minus 2 is 8 and 5 minus 3 is 2 is in 4. Now the average velocity between P1 and P3 is different. So that itself shows about its non-uniform motion. Now can I calculate one more? You stay with me. So it is the average velocity between P3 and P4. From the same graph you calculate the average velocity between P3 and P4. Now velocity v bar equal to same formula, x2 minus x1 upon t2 minus t1, is equal to x2 value is p3, I have taken that 2, and x1 is on p4, its value is 0, and time t2 here it is 3, and t1 equal to 1. So you can guess these numbers, that is t2 and this is t1. So if you can do that, 2 upon 2 its value equal to 1. So average velocity between p3 and p4 equal to 1. Finally, what is the average velocity between 0 comma 1? The average velocity between, if I can take one more point, so at here p5. So try to calculate the average velocity between p4 and p5, the 2 points. Now v equal to x2 minus x1 upon t2 minus t1. Here the x2 x1 upon, they both are at 0 only, so I can get 0 upon 1 minus 0, the velocity v equal to 0. Now if I can say, so between 1 and 2 the velocity equal to 0, between 1 and 3 the velocity equal to 1, average velocity, between 3 and 7 the velocity, between p1 and p3, 3 to 5 is velocity is 4, and 4 to 7 the velocity is 8.7. Now by taking this, I would try to plot the graph. Now on the time axis, and here it is velocity. So it is 0, 1, 2, 3 and 4, 5, 6, it's 7. On the y-axis, how much I can take? I need to take up to 0 to 8.7. So let me take as 2 interval. So 2, 4, it's 6 and 8. Yeah. Now from the graph, between p4 and p5, so p4 and p5 is nothing but in the time axis between 0 to 1. So between 0 to 1 the velocity equal to 0. So how can I represent that? I need to represent between 0 to 1 the velocity equal to 0. So I put that 0 to 1 the velocity equal to 0. And between 1 to 3, so 1 2 3, it means from here to here, between p4 and p3, from p4 and p3, so what's the velocity I got that velocity equal to 1. So between 1 to 3 the velocity value equal to 1. Suppose here you can take the value of 1. Now I need to draw a line from 1 to 3 equal to 1. And how did I fill this, the vertical gap? The vertical gap I need to fill just like a step, because they both are at 1 only, so like that I need to fill. Now after 1 to 3 is over, now between 3 to 5, 3 to 5 means 3 to 5, this is this segment. From 3 to 5 segment means p3 to p1. So p3 to p1 I got it at here. Yeah, p3 to p1, its value is 4. So now I need to plot the graph between 3 to 5, the value is 4. Now I'll take again straight line between 3 to 4, that is exactly at 4, 3 to 5. Now these vertical lines also I need to add up. Now finally between 5 to 7 means between P1 and P2. So this is between P1 and P2, the value here it is 8.7. Between 5 to 7, 8.7, if I can take roughly at here, so I can take that at here, 5 to 7. Now I need to fill this vertical line like this. Wow, it's just like step. Now finally I can conclude by saying that. So let me make it group so it won't go away. So this is velocity time graph. So this is velocity time graph if this is position versus time graph. Oops. So if this is position versus time graph, the curve, and if you can see the difference of the how the velocity versus time graph became. So for non-uniform motion, so this is a non-uniform motion position versus time graph, and now this became for non-uniform motion velocity versus time graph. So how did we plot that? We plotted by taking segments for non-uniform motion. Yeah, non-uniform motion graph plot is difficult because every time the velocity is different. So if the velocity is different, we need to calculate that. And here I have taken a very small, less segments. So that's why it came up like that. So this is a way how to draw graph for, this is for non-uniform motion. Position versus time graph, the corresponding velocity versus time graph. And likely if we can go ahead for uniform motion, yeah, this is for uniform motion, everything is mess. So if this is uniform motion, the velocity versus time graph is straight line. Yeah, if this is uniform motion, the velocity versus time graph is just a straight line. So because uniform motion having constant slope, and if this is an object is at rest, the the velocity versus time graph is also a straight line, but it is on the time axis 0 itself. So this is how we draw position versus time graph to velocity versus time graph. And here we already understood the slope of the curve gives the velocity. So if you can calculate the slope of the given curve, that gives us the average velocity. So in the coming concepts, we will calculate exactly instantaneous velocity. What is the instantaneous velocity? It's something says about you want to find velocity at given particular time. So at this particular time, by using the graph, what is the velocity at this particular time? So that concept we will discuss in the next lecture.